Hello everyone, I am Ece Nur Kızıklı. I'm majoring in computer science at Bilkent University and this is my Phys102 project. In this experiment, I investigated Faraday's law of induction using solenoid coils and the moving magnets. First, I would like to talk about the materials I used. I used 3 solenoid coils with 100, 200 and 400 turns, a cylindrical permanent magnet attached to a metal rod, a voltmeter to measure the induced EMF, a ruler to estimate distance and velocity, and a phone camera to record the trials for later analysis. During the experiment, I guided the magnet through the center of each coil at approximately 1, 2, and 6 centimeters per second. The aim of this experiment was to verify Faraday's law, which states that a changing magnetic flux through a coil induces an electromotive force, or EMF. In this setup, the magnetic flux changed as the magnet moved through the solenoid. I also wanted to observe how the induced EMF changed depending on the magnet's velocity, the number of turns in the coil, and the orientation of the magnet. According to the theory, the induced EMF should increase when the magnet moves faster, and it should also increase when the number of turns in the coil becomes larger. In addition, when the magnet's orientation is reversed, the polarity of the induced EMF should also reverse, as predicted by Lenz's law. My experimental results were consistent with these expectations. For all 3 coils, the induced EMF increased as the magnet velocity increased. Also, at the same velocity, the 400-turn coil produced the highest EMF, the 200-turn coil produced intermediate values, and the 100-turn coil produced the lowest values. This shows that the EMF increased with the number of turns. Also, since the magnet poles were not labeled, its 2 ends were referred to as pole A and pole B, and when the orientation was reversed from pole A first to pole B first, the polarity of the induced EMF changed from positive to negative. This is consistent with Lenz's law. Lenz's law states that the magnetic field that is produced by an induced current will oppose the change in magnetic flux, which caused the induction. Although there were small deviations between some trials due to hand-controlled motion, alignment differences, and measurement uncertainty, the overall trend was very clear. Therefore, the experimental results strongly supported the theoretical predictions of Faraday's law of induction.